my dear student. This is Bijay sir, your chemistry teacher. Today I have made a video for the student of class 10th under the first chapter chemical reactions and equations. And the topic is non-redox reaction. Dear friends, we have learned in this chapter through a series of videos different kinds of chemical reaction, namely combination reaction, decomposition reaction, displacement reaction, double displacement reaction, and redox reaction. The redox reaction has two parts, oxidation reaction and reduction reaction, which are the two half part of a chemical reaction, about which we have learnt in the last video in detail. Today I would like to make you understand another kind of chemical reaction which is related with the redox, which is related with the concept of redox reaction, called non-redox reaction. Some chemical reactions are there in which it is found neither a reactant undergo oxidation and nor a reactant undergo reduction. Means none of the reactant is oxidized and none of the reactant is reduced. Such chemical reactions are called non-redox reaction. Clear? We have read in redox reaction, loss of electron and gain of electron take place. The oxidation number of element during oxidation increased. The oxidation number of element due to reduction is decreased. But if in any chemical reaction, the oxidation state of the same element in the reactant and the product, it remains the same. Means charge of any of the element due to the reaction do not undergo change. Such chemical reactions are non-redox reactions. In some of the chemical reactions, none of the reactant is oxidized and none is reduced. Such chemical reactions are called non-redox reactions. we should understand this reaction by taking some examples. Very simple example. First of all, I would like to provide you, which is very popular reaction, and all of you are familiar with this reaction. You have been reading this reaction for many years. In your previous classes, you have read this reaction many times. Calcium carbonate CaCO3 is known to you all. When it is heated, it undergoes thermal decomposition to give calcium oxide and carbon dioxide. Now, decide the oxidation state of each element in the reactant and the product. The calcium is alkaline earth metal. Its oxidation state is +2. Oxygen in a compound and ion, the oxidation state of oxygen is -2. Here we need to calculate the oxidation state of carbon. Calculate the oxidation state of carbon in calcium carbonate. +2 plus x minus 6 is equal to 0. Therefore, x is equal to +4. To use +4 charge on carbon atom in calcium carbonate. Again here, in calcium oxide, calcium is alkaline earth metal which always possesses the oxidation state +2. And oxygen in a compound possesses the oxidation state -2. And here the oxidation state of oxygen is -2. And we need to calculate the oxidation state of carbon in carbon dioxide. Let the oxidation state of carbon is X. And oxygen -2 into 2 is equal to 0. Therefore, X is equal to +4. Here, in carbon dioxide, the oxidation state of carbon is +4. Now, look into the change in oxidation state. Here it is quite clear. None of the element of reactant undergo change in its oxidation state in the product. The oxidation state of calcium is +2 in reactant and it is +2 in the product also. Similarly, oxygen +4 in the reactant, +4 in the product. Oxygen -2 in the reactant and -2 in the products also. The neither decrease in oxidation state nor increase in oxidation state. Means no change in oxidation state takes place. Therefore, this reaction is not a redox reaction. It is called non-redox reaction. I think the concept of non-redox reaction is clear to you all. I would like to provide you some more examples so that you will be able to identify the chemical reactions given are redox reaction or non-redox reaction. AgNO3 aqueous solution, NaCl aqueous solution. We have read this reaction in a previous kind of chemical reaction. You may recall from your memory which kind of the chemical reaction is it. Which kind of this chemical reaction is, we have rate. It gives NO and ANO3 aqueous and AgCl solid. It is a double displacement reaction, which is also called here precipitation reaction. Right? We have rate in double displacement reaction, this example. Now, here we have to decide this double displacement reaction, this precipitation reaction is a redox reaction or a non-redox reaction. For that, again we need to decide the oxidation state of each element in the given compound, in the reactant and the product. Silver plus 1, nitrogen you calculate here, plus 1, AgNO3 is equal to 0, silver plus 1, nitrogen plus X, oxygen minus 6 is equal to 0, X is equal to plus 5. Sodium is alkali metal plus 1, chlorine is halogen in halide minus 1, sodium plus 1, oxygen minus 2. Like AgNO3, you will calculate the oxidation state of nitrogen here. You will have plus 5, here silver plus 1 and chloride. Silver chloride, chlorine possess minus 1 oxidation state. And again look into the example. None of the element undergo change in their oxidation state. The oxidation state of each element in the reactant is equal to the oxidation state of that element in the product. Therefore, it is not a redox reaction, so it is called non-redox reaction. This is how we can decide the redox and the non-redox reaction. Now, a question is asked. After knowing the redox and the non-redox reaction, after having the concept of redox and non-redox reaction, you are not able to solve the questions asked in the form like this. Identify the substance, means reactant, oxidized and reduced. If any, in the following chemical reactions. In this question, if any is given, we have learned all chemical reactions are not redox reactions. Some chemical reactions are there which are non-redox reactions. In non-redox reaction, there is no question of any substance to be oxidized and reduced. Therefore, in the question, if any is given. So in the list of the reactions, you will have some reactions which are redox reaction and some reactions may be in the given list which are non-redox reaction. In redox reaction, we shall identify the substance oxidized and reduced, and if in the given list any of the reaction is non-redox reaction, we shall simply mention non-redox reaction. Right? By mentioning non-redox reaction, it becomes clear that in this reaction there is no question of any substance to be oxidized and reduced. So now some list of questions though I would like to give you, as in the examinations the questions are asked. Say PCl3 plus Cl2. Right? Phosphorus trichloride reacts with chlorine to form phosphorus pentachloride, PCl5. Second question, we can write 2KClO3 potassium chlorate undergo decomposition reaction to form 2KCl3O2. Magnesium oxide plus hydrochloric acid to form magnesium chloride plus water magnesium chloride plus water. Fourth, ZnCO3 plus H2SO4, ZnSO4 plus H2O plus CO2. Next reaction we can write Zn plus 2 NaOH, sodium hydroxide. When zinc metal react with alkali solution, sodium hydroxide, it forms sodium zincate, Na2ZnO2 with the liberation of, along with the liberation of hydrogen gas. The Na2 ZnO2 plus H2. Right? These are 5 reactions given, and in these reactions we have to identify the reactant oxidized and reduced, if any. They start, and to understand the answer of these questions, PCl3 is a chloride in which the oxidation state of chlorine is minus 1. And we need to calculate the oxidation state of phosphorus in this compound. X minus 3 is equal to 0, therefore X is equal to plus 3. Use plus 3 oxidation state of phosphorus here, and chlorine Cl2 is in uncombined state, means in freeze state, therefore oxidation state of chlorine is 0, and here the oxidation state of chlorine, again it is chloride, phosphorus pentachloride, minus 1, therefore the oxidation state of phosphorus will be plus 5. Now look into this reaction. Here, chlorine, the oxidation state of chlorine, we have to look into the change. See, the oxidation state of chlorine is minus 1 in PCl3. The oxidation state of chlorine is minus 1 in PCl5 also. Means the change is not taking place due to chlorine. Change is taking place due to phosphorus. The oxidation state of phosphorus is changed from plus 3 to plus 5. Means it is the oxidation state of phosphorus is increased. Therefore it is oxidized. And the oxidation state of chlorine is decreased. Therefore, chlorine is reduced. Clear? In the next reaction again, you used to write the oxidation state of oxygen minus 1. Potassium is alkali metal plus 1. You need to calculate the oxidation state of chlorine in this compound. KClO3 is equal to 0, K plus 1, chlorine X, oxygen minus 6 is equal to 0, X is equal to plus 5. The oxidation state of chlorine is plus 5. Here potassium plus 1, chloride minus 1, and oxygen in elemental state is 0. Now, this is another kind of redox reaction in which the same substance undergo oxidation as well as reduction. Here KClO3, a part of KClO3 is reduced, in which the oxidation state of oxychlorine is changed from plus 5 to minus 1. Means KClO3 reduced to form potassium chloride, and the same compound KClO3 oxidized to form oxygen, because the oxidation state of oxygen is changed from here the oxidation state of oxygen is minus 2. Is changed from minus 2 to 0. Increase in oxidation state of oxygen takes place. Therefore, KClO3 undergo oxidation due to the change of oxidation state of oxygen, and the potassium chlorate undergo reduction due to change in the oxidation state of chlorine. Clear? Here the same substance is oxidized and reduced. Now in the next reaction, magnesium is alkaline earth metal plus 2, oxygen minus 2, hydrogen plus 1, chloride minus 1, magnesium plus 2, chloride minus 1, hydrogen plus 1, oxygen minus 2. It is a very simple reaction in which the oxidation state of each element in the reactant is equal to the oxidation state of the same element in the product. Therefore, it is not a redox reaction, so we shall simply mention here non-redox reaction. Clear? Now in the next reaction, the oxidation state of oxygen is minus 2, zinc is plus 2. You calculate the oxidation state of carbon, it will be plus 4. Plus 1, oxygen minus 2. You calculate the oxidation state in the rough paper. You know now to calculate the oxidation state of sulfur. It will be plus 6. Plus 2 plus 6 minus 2 plus 1 minus 2 plus 4 minus 2. Again, you look into the change in oxidation state. None of the element undergo change in the oxidation state. Therefore, it is also a non-redox reaction. In this reaction, zinc is in the elemental state, in uncombined state. Therefore, oxidation state of zinc is 0. Sodium is alkali metal plus 1, oxygen is minus 2, hydrogen is plus 1. Sodium is alkali metal plus 1, oxygen is minus 2. You need to calculate the oxidation state of zinc in this compound. And you can calculate like this: Na2ZnO2 is equal to 0 plus 2 plus x minus 4 is equal to 0. X is equal to plus 4 minus 2, that is plus 2. You will write here plus 2, and here hydrogen is in elemental state, therefore oxidation state of hydrogen is 0. Now look into the change. Here change is taking place. Zinc, the oxidation state of zinc is changed due to this chemical reaction from 0 to plus 2. And the oxidation state of hydrogen is changed from plus 1 to 0. Therefore, zinc is oxidized to form sodium zincate. We shall say zinc oxidized to form sodium zincate, and sodium hydroxide reduced to liberate hydrogen gas. Plus 1 to 0. Decrease in oxidation takes place. Therefore, it is reduced. I think now it is clear to you all that how can you decide the reactant oxidized and reduced, and also you are now able, you have the concept to decide the reaction, nature of reaction, whether the chemical reaction is a redox reaction or a non-redox reaction. Okay, thank you.